Assalamu alaikum students. Hope you all are fine and healthy. Students, let's start a new chapter of physics, that is chapter number 12 of your science 2 book, named A Transmission of Heat Energy. So, our objectives for today's lecture will be heat on move, conduction, applications of conduction, and then the conclusion. But before starting, I request you all to please be attentive during the lecture, as this time as well I have tried my best to make the lecture more interesting and comprehensible for you all, as this chapter is very important not only from your exams perspectives, but also it is forming a base for many other topics of physics that you will learn in your higher levels. So let's start. So students, basically in this chapter we will learn how the heat energy transfers from one object or one body to another object or body, and how it transfers. So heat is a form of energy that can be transferred from one body to another, and this process takes place by the help of a diffusion. You people must be aware of this term in your biology classes as well, that heat is transferred from a region of higher temperature to one of the lower temperature. As you can see here in this diagram as well, that this saucepan gets heated when it is placed on this red hot coil. As soon as this pan gets heated, the water inside it starts boiling. So this all happens due to the transmission of heat energy from one body, that is the red hot coil, to another body, that is this saucepan. So now a question arises here, that how is heat transferred between objects and their surroundings? So as we have discussed earlier, that heat is a form of energy that is transferred from a region of a higher temperature to one of the lower temperature. A cold object placed in a warm place will absorb heat from its surrounding, causing its temperature to rise. And on the other hand, a warm object will lose heat to its surroundings, causing its temperature to fall. So this transfers basically takes place in three different ways. One is conduction, other is convection, and the third is radiation. Now let's try to understand these three terms by the help of one example, as there are three. So let's discuss the three possible ways of getting a book to the back of the class. There can be three possibilities. Either the boy can throw the book at the back of the class, or he can pass it on from one person to another to make it reach the back of the class or the end of the class, or he can carry the book himself to the back of the class. So let's discuss these three instances in comparison with these three different ways of heat transfer. The first way of transferring heat is known as conduction, whereby energy is passed from one vibrating molecule to the next in their fixed position. This process basically mostly takes place in solids. So this is similar to passing the book from one pupil to another without anyone leaving their seats. The second is convection, in which whereby energy is carried by molecules moving from one place to another within a liquid or a gas. So most of the times this process takes place in liquids. So this is similar to having the book carried by one student who then moves to the back of the classroom. The third way of transferring the heat is known as radiation, whereby heat in the form of electromagnetic waves is emitted in all directions, for example at the speed of light. Which is similar to the way that a book are being thrown to the back of the class without any carrier. So what do you say, students? Which of the way is the fastest way to get the book to the end of the class or to the back of the class? So now let's discuss these three terms in a bit detail. So the first way to transfer the heat from one body to another is conduction, whereas the conduction is the transfer of heat from a material transfer of heat through a material from the hot to the cold region without any visible movement or flow of the material. As we have seen in the previous example as well, that the person or the boy was passing the book from one person to another without leaving their seats, and in this way the book will reach the end of the class. And the same is the case with the conduction. The molecules starts to vibrate, remaining at their mean position, and thus transfers the heat from one atom or the molecule to another. And in this way, the whole object gets heated. So this process mostly takes place in solids. And metals are very good heat conductors because they have many free electrons which can transfer heat. So whenever you heat the object, the molecules of that object starts to vibrate, and in this way the electrons absorbs the heat and starts to flow or move within the object, thereby heating the whole object. So conduction mostly takes place by a direct contact. For example, as you can see here in this diagram, that when you places this saucepan on the Bunsen burner, after some time it will absorb the heat from the burner, this object, and whatever is inside it will start to boil. But before this, whole the pan will become hot, and the handle of this pot or this pan will also be hot. Why? This is because of conduction. that the molecules of this pen starts to vibrate and starts to transfer the heat from one molecule to another, and in this way the heat will reach this handle and thus making it hot as well. So that is why on the handle object like plastic or wood are used, so that it will be easy and convenient for the person to hold the pen, as the plastic and the wood are the bad conductors of heat. So students, let's discuss two important terms related to this topic, that is the conductors and the insulators. Then we'll be able to understand the first way of transferring the heat from one object to another very easily. So in a conductor, electric current or heat can flow freely. As we have discussed earlier in the previous slide, that the conductors or the metals such as copper typify conductors because they have free electrons that upon heating starts to vibrate, starts to move within the vessel, and hence transfers the heat from one molecule of the same object to the other molecule of the same object, and hence thereby making the whole object hot. Whereas in an insulator, current or heat cannot flow freely. As I have told you earlier, that is the reason why the plastic and wood are used on the handle, so that it will be easy to grab the pan or any hot utensil. So most non-metallic solids are said to be good insulators, having extremely high resistance to the flow of charge through them. Most atoms hold on to their electrons tightly and are insulators. You people must be familiar with the term or the rule that is known as octet rule of the atoms in your chemistry classes, that every atom, like humans, wants to get stable, and they get this stability by completing their outermost shell with the fixed amount of electrons. So once the atoms complete their octet, so it is then impossible for them to unhold their electrons of their outermost shell, and thereby they become the insulators, whereby such atoms, for example different types of metals that are unable still to complete their octet or their outermost shell with the fixed amount of or the recommended amount of electrons in their outermost shell. So upon heating, the electrons in their outermost shell absorbs the heat and starts to move freely from one atom to another atom. That is the reason why we are saying that metals, most of the metals are conductors, and most of the non-metals, for example plastic, fur, wood, etc., are insulators of heat, and probably the electricity as well. So as you can see here in the diagram as well, that this is basically the list of the conductors and the insulators, starting from bottom to top. The good conductor is lead. Iron is better than lead. Aluminum is better than iron. Copper is better conductor of heat than aluminum, and the silver is best conductor among all of these metals. Whereas water is also an insulator. We'll be discussing an experiment related to this, then you will be clear how water is considered as a bad conductor of heat. Glass is also an insulator. Cork is a more insulating material as compared to glass and water. Air is also an insulator, and vacuum is one of the most insulating material in comparison to all these mentioned here in the list. So now let's have a better understanding of this topic with some of the practical examples.
Transfer of heat, conduction. Objectives: to see the different modes of heat transfer. Definition of conduction of heat. To understand how conduction occurs. We receive heat from the sun. A vessel kept on a burner gets heated on the top even though the flame is at the bottom of the vessel. Now, if we pour some water into this vessel, then the entire amount of water gets heated, in spite of the flame being at the bottom of the vessel. In all three instances, heat is getting transferred from one point to the other point. But how does this heat transfer occur? Basically, heat gets transferred by three modes: conduction, convection, and radiation. We shall first see the conduction mode of heat transfer. Let us take a look at a simple experiment. With the help of wax, stick nails at equal intervals on an iron rod. Now, heat one end of the rod. You can find that within some time, the nail nearest to the heated end falls off. After some time, the nail next to it falls off. In this order, all the nails fall off the rod with time. Why does this happen? The iron rod is made up of atoms, which are constantly in close contact with each other. When the rod is heated from one end, the atom which is near the flame gets heated first. Then, this atom, while remaining in its position, transfers heat to the adjacent atoms. These atoms, in turn, transfer heat to the next atoms. Similarly, loosely bound electrons also transfer heat energy. The free electrons, after acquiring the heat energy, drift through the metals and transfer heat energy by colliding with other atoms, as well as other free electrons within the metal rod. When the point where the nail is stuck to the rod gets heated, the wax melts and the nail falls off. As the heat continues to get transferred through the rod, the nail falls off. In this way, heat gets transferred through the rod. This type of heat transfer is called conduction. Hence, conduction is defined as the process of heat transfer, where heat is transferred from one atom to the other without the actual displacement of atoms. Hence, when conduction happens, two characters come into play: atoms, or molecules and electrons. Conduction occurs mostly in solids like metals. Let us perform another simple activity. Take a test tube filled with water. Take a piece of ice and wrap a copper wire around it. On dropping this ice piece into the test tube, it settles to the bottom of the test tube. Now hold the test tube in a tilted position over a burner. The water at the top of the test tube starts getting heated. As we continue heating the test tube, the water at the top starts boiling. But still the ice at the bottom of the test tube does not melt. This means that water at the bottom has not yet been heated, and heat is not yet transferred to the bottom. This experiment clearly shows that liquids do not conduct heat as easily as solid, because the molecules of liquid are not arranged in close contact with each other. In comparison to liquids, gases fare even worse while conducting heat. But how does heat get transferred in liquids? Heat transfer in liquid takes place by a phenomenon called convection. We shall study this in our next topic. Process of heat transfer, where heat is transferred from one atom to the other without the actual displacement of the atoms. Conduction occurs only in solids.
So I hope students know your concepts about the conduction way of transferring heat from one object to another are now clear. Let's move on to the next topic, that is everyday application of conduction. So there are different everyday processes that make use of conduction process. The first one is in the soldering iron, also known as tavia. So this soldering iron has an iron rod with a copper tip. So why the tip is made up of copper, not of iron or any other metal, as we have discussed that copper is best conductor of heat. That's why the tip of this soldering iron is made up of copper. So this instrument is used in many different types of things or the matters by the engineers. For example, in joining two different wires, or you people must have seen the motherboard of the CPU or other electronic devices. So that motherboard is also made by the help of this soldering iron. Let's see how it works by the help of a practical example.
Welcome to my how to solder video. This is for beginners, but I'm also going to try to make it as quick and fact-filled as possible. Here's my first soldering iron I ever owned. This is like a Radio Shack. Has a 15 or 30 watt switch. This is a butane soldering iron. These are very handy if you have to work on stuff away from electricity. This is my soldering station I finally bought. It's probably 100 watt. People usually stay between about 315 and 370 C. So if you have a little surface mount job, you probably want as sharp of a tip as you can get, but you want to keep your temperature closer to 315 C or 600 Fahrenheit. You need to be quick too, because too much heat and you can burn them up. I have a sponge here to clean my tip. I usually keep some water here so I can just get things wet. You need to keep your tip clean, so before you start soldering you need to put some fresh solder on and go ahead and clean it off. For soldering electronics, you definitely want rosin core solder. Acid core is not for electronics. It'll mess things up. In the old days we could get some good lead solder. Lead free. It has a slightly higher melting point, but for all intents and purposes it's the same. So when you're going to solder, and by the way, it's solder in the United States and solder on the other side of the pond, so please don't write stupid YouTube comments telling me I'm pronouncing it wrong, because you can pronounce it both ways. So for starters, I'm going to get a little solder on my tip, and then I'm going to get the pieces of metal hot and then apply solder to the hot metal. And I use a quick upward motion to kind of make the bubbles look good. but you definitely want to get the metal hot, and you want to apply your solder directly to the metal. The reason you do this is because there is flux. This is rosin core solder, and the flux will burn off. So if I just put it on my iron and let the flux burn off, and then I try to stick it to it, it doesn't really stick to the metal that great. But if I put some fresh solder on there, it'll go ahead and melt in good. So if you're going to solder a couple of wires together, the most common method is to twist the wires together. And then if you have something like a helping hand, that is very helpful. Otherwise it's quite a pain trying to hold a couple pieces of wire together. So first thing you need to do is get the wire hot. So you're going to get some solder on here so that it starts conducting the heat to the wire. Once the wire is really hot, smoking hot, you can go ahead and apply the solder. Notice how I'm applying the solder to the wire, and the wire is just wicking the solder in. And you want to do this pretty quick, otherwise your insulation will start to melt. So now that you have your wire, what do? Well, if you're poor, you will use some electrical tape to cover up the wire, or you can use some heat shrink tubing. So another point to mention is that you need the rosin to make the solder stick to the wire. However, solder will stick to solder no problem. So if you tin your wires really nicely and you get the solder sticking to the wire, you can actually reheat solder. And even though this isn't twisted together, so people are going to get me in the comments because this isn't the way you're really supposed to do it. It actually is pretty sturdy. It's a good solder connection, but mechanically there's not a very good connection. If you first twist the wires around each other, there's more metal to metal contact, and then when you apply the solder, it gives you a little better connection. One of the most
Another application of conduction is riveting. You people must remember this riveting process we have discussed in our previous chapter in the topic of application of thermal expansion and contraction. So this process is also helpful in joining two metal plates or two metals. This also works on the principle of conduction. The other uses of conduction are iron press. So as we have discussed about this iron press in our previous lectures as well, that it makes use of bimetallic strip in order to make the connection complete and automatic of this iron press. So now when you apply the electricity to this iron press, that electricity transforms in a form of a heat, and then you will be able to press your uniform. So this all process, or this whole the iron press works on the principle of conduction as well. Another example of conduction is in this cooking pan. So this saucepan gets hot whenever it is placed on the red hot coil. Another very important application of conduction is this van der Waals, or you can say that thermal cooker. So this is basically the outer look of this thermal cooker or the van der Waals. And this is basically the construction, how it is constructed with the help of stainless steel, stainless steel lid, stainless steel inner pot, and the insulated outer pot. So it makes use of heat or the thermal energy, and as the outer surface of or the outer body is made up of the insulated material. So when after heating, when you place the inner pot inside inside this cooker again, by the help of its insulating outer body, the heat will be trapped inside this cooker, and at the time of meal you will be having your fresh and hot meal. So conduction also takes place in this van der Waals as well. So as you can see here in this diagram, that this person is holding this inner pan of this van der Waals by the help of a cloth, which clearly shows the process of conduction has taken place in this van der Waals as well. So let's see practically how this van der Waals works, and how it works on the principle of conduction. To cook the food, as well as how it works on the principle of conduction. And by the help of this example, you will also be able to know how the insulating materials are fast conductors of heat. But meanwhile, it is also very cost effective in terms of saving the electricity, or in saving the heat energy, and thereby reducing your gas bill. So another application of conduction is these cooking utensils, for example saucepans, frying pans, boilers, etc. And another application of the conduction is in this electric bulb or this energy saver. So when you switch on the bulb, the current or the electrons starts to move in this electric bulb, and hence making this whole bulb glow, as well as making it hot as well. But due to the presence of air inside it and due to the presence of an insulating material around this bulb, the heat is trapped inside this electric bulb. As we have discussed as well, that air is a bad conductor of heat, and so you do not feel warm if your bulbs are on for 24 hours. Some of the other applications of conductions can be seen in these two instances as well. The heat from a hot coffee makes the cup itself hot, so making for you to hold this cup from this part as well. This part you can only hold the cup from the handle, or a metal spoon becomes hot from the boiling water inside the cup. Therefore, after placing the spoon for 2 to 3 minutes, you will be unable to hold it again with your bare fingers, because the spoon gets hot, and this happens because of the principle of conduction or the process of conduction. So these were some of the applications of conduction in our everyday life. You can find out some other examples of regarding this topic, that is application of conduction, and so that it will be more convenient for you to understand this topic. So let's have a review that what we have discussed in today's lecture. First, we have discussed heat on move. Then we have discussed first process of heat transfer, which is known as conduction, and two major terms related to this topic were conductors and insulators. And in the end, we have discussed the applications of conduction. I hope, students, up till now your concepts regarding these topics are pretty much clear. And now I will be eagerly waiting for your positive replies. In our next lecture, we'll be discussing the other two ways of transferring of heat from one object to another, that are convection and radiation. So, till then, take care of yourself a lot. Thank you, and Allah Hafiz.